This conference will now be recorded.
Well, very good morning. Morning. So let's start with tools today, and we'll be starting with repository tools. I think we know the purpose of repositories, right? So developers that push the code to the repository, and so that every change which is done by the developer towards the repository will be maintained some history. Okay. So source code. So sharing, that's a major reason why we need a repository. So what are the major advantages why we need repositories? The first advantage is, so that's code sharing. Okay. So why repositories? For source code sharing. So if you like to share the code, so developers, they work in a team, right? If developers work in a team and they need to share the code among themselves, how the sharing happens? Through the repository. Why through the repository? Because the repository works as an centralized, right? So repository is nothing but your centralized folder. You can say it's kind of folder. You can see that whole project on that particular repository. So yes, so that is why we need a repository for sharing purpose. But, and other reason is for version controlling. Right. So what is version control? Every change which is done by the developer towards repository or towards the project, which is recorded. So in what forms they will be recorded? In the form of versions. For example, developer, there's a developer 1. And this developer 1 has modified some file. So the file was modified by developer 1. So he saved he has done some changes to the file. And so whenever developer 1 has done some changes to the file, and there will be some version created. That's a unique version. Okay, the version something like is some random numbers. Okay, so that is what we call version number. And so in some repositories, the versions will be something like in numbers like 1, 2, 3, 4, so on. So version numbers are given like in sequence. For example, developer 1 has done some commit. Then that version is 1. If you are a developer 2, I have done some changes. The version is 2. Then it is incremented 1, 2, 3, 4, so on. But in terms of Git and GitHub repositories, the version IDs, or you can say commit IDs, version numbers are generated in random numbers. And that number is, so this version contains about 32 numbers. The version contains how many numbers? 32 numbers. Why can't they generate something like 1, 2, 3, 4? So there is a reason. So why Git follows this kind of version? So there is a reason. We'll talk about that as a part of architecture. We'll talk about it. Why that versions are not given in sequence wise? Why they are in random numbers? There is a reason actually. Okay. So there are some repositories like Subversion, SVN. Okay. In those SVN concept, the versions are given 1, 2, 3, 4, so on, sequence. There is a sequence, but not in terms of Git or GitHub. Okay, but we'll come back to that. Then what is the other reason we need version control tools? Centralized, yeah, we already have done it. And code sharing, version controlling. Then one major reason. What is that? Security. So security. So I can provide some security, saying that, for example, let's say my developer team has about 10 developers, and all these developers, they can do modifications on the repository. Am I clear? Only they can access, and plus they can do changes on the repository. For example, I'm not a developer. Still, I want to see the project code. I can see it, but can I do the modifications? No. Or else you are from outside of my team. Let's say you are not a developer, you're not a tester, so you're not nowhere related to my project, but you want to access my code. Can you do it? No. So you don't have access to at all to access my repository. But developers can modify it. I can see the code. Let's say I'm a client. I want to see your code. I can see the code. But developers, they can see it, they can modify it. Okay. So these kind of securities we provide to the repository, like who can modify it, or who can read it. One second. Who can read it, or no access. So we can provide these type of securities. Yeah. What is the question?
So version given the numbers 1, 2, 3 time being, sir?
We don't give the numbers. The numbers of versions are randomly generated. We don't give the numbers. Okay. So version numbers or version IDs, these numbers we don't provide them. Those numbers are automatically generated. We don't provide the numbers. That's a technique of repository. Okay, we don't provide the numbers.
Time being is the detail of times version is
We'll talk about that. Okay. Right. So these are the major reasons. So why we need a repository. Okay, fine. Now we understand the purpose or the importance. But we don't have a repository concept. Okay. So then still I want to maintain my project as in centralized for sharing purpose. Is it possible? Let's say there is no repository concept. If there is no repository, can I still do that access? Can I still maintain that code as centralized? Can the developers share that code? Is it possible? How? How is that possible? So when you go to your projects, okay, you might come across network shared drives. What do you mean by network shared drives? For example, the whole development team, they have a folder. Okay, that folder is over the network. And why that is on the network? Let's say it's on what network means it's on common server. And that folder or that particular repository, so not repository, sorry, the network shared drive can be accessed by multiple developers. Do you have a repository concept? No, this is just like a folder. That folder developers do commits. They do the changes to the folder itself. What that folder contains, just like my project. Am I clear? Understand this? So the concept is network shared drives. Okay, we can go with network shared drives, right? Why we go with repositories then?
network shared is which you access, they can delete or modify itself.
Yeah.
That provides security.
Of course, we can provide security to network shared drives. If there is no network, if there is no security, there is no purpose of going for networks.
There are multiple multiple teams. Like
Within the network only we can access, sir. I mean,
One second. Give a break. Okay.
restoring the data.
We store the data.
The
Okay. Fine. Yeah, that is correct. So here we talk about, say, network shared drives is not possible to do version control. You know what is version control, right? I give an example yesterday. So it's not possible to provide. It's not possible to provide this kind of concept called version controlling concept through the network shared drives. That's not possible. That's one reason. So the drawbacks. What are the drawbacks for network shared drives? So no version control, no VCS. Okay, that's one drawback. That's on shared drives. And other drawback. Okay, you might not be knowing it. Other drawback is, for example, there are two developers. They're trying to modify a same time. Then whose changes will be committed first? If first developer changes are committed, are saved, How about the second developer changes? But even second developer changes are important.
Or
If it is overrides, how about the developer one changes?
maybe just as a second version.
So for me, I want to maintain both. Because as a developer, I feel that both changes are important for me. If second developer changes are overridden, then how about the first developer changes? So that is what we call a conflict. So these kind of conflicts we can resolve with help of repositories. So, but if you go with shared drives, so you cannot resolve the conflicts. So now, if you have this question, so see those who are towards, I mean, in organizations or in interviews, especially if their concentration is towards repositories, so that is one of the questions. I don't have a repository, I don't have any version control tool. So how you going to manage my project code as a centralized? If so, why? What are the drawbacks with that concept? That means what are the drawbacks with shared drives? And what are the advantages? How do you compare with shared drives? Okay. Well, so now we understand the importance of Well, sorry. Yeah, let's continue again. I'm sorry. Yeah. So now we understand the importance of repositories. Now let's talk about type of repositories. So you can have two types of repositories. One is server-based repository, cloud-based repository. So which one is preferred? Well, I'll come back to that point later. So I think so. I'll just take your question at the end of the session. But anyway, okay, fine. So let me just go with it. What are the drawbacks if you go with network shared drives? 1 second, let me take the question again. Sorry, it's got disconnected. Okay. So what are the disadvantages for network shared drives? So first is we cannot do version controlling. And then other thing is conflicts. So it's not possible to resolve the conflicts. So what is a conflict? If multiple developers are trying to modify the same file, okay, and whose changes will be committed first? Whose changes are important? So of course we know that. So for example, developer 1 is committing around 957, and there is developer 2. He has committed about at 958. Then developer 2 changes are important. His changes will be committed, right? But what if they are committing within fraction of seconds or same time? Whose changes are important? So that is what is a conflict. Network shared drives, then the network shared drive doesn't understand how to resolve these kind of issues. But repositories, we can resolve this kind of conflicts. Okay, so these are your drawbacks with network shared drives. So that's the reason we use repositories. Hope that was clear. Good. So, and then server-based repository. What are the examples? We have SVN subversion. SVN stands for subversion, and there are other tools like TFS. So these are a couple of examples. What is the other one? Bitbucket. So Bitbucket. So these are the few examples, and for server-based repositories. So what do you mean by server-based repositories? What is server-based repository? So if you want to use these repositories, if you want to create these repositories, first install these repositories or install these tools on some servers. Once you have a server, so very simple. So first you have a server first. That's a server. On this server, you install your tools. So whatever the tool that is, TFS or Bitbucket, so install those tools. Once these tools are installed, then we start creating repositories on this server. Now, what is the drawback with this concept, server-based repositories? Maintenance. So the drawback with server-based repositories, server maintenance. What do you mean by maintenance?
Load imbalance.
Yes. When you talk about maintenance, the first thing is server performance. That's important. So server needs to be always running with high performance. So whether one developer use it or 100 developers use that repository from that server, and the server needs to be reacting, response time has to be the same. If 100 developers are trying to do commits same time, then the response time from the server has to be high, and even one developer do it, response time has to be high. That is what we call server performance. Other thing is high availability. What is high availability? So we are not expecting any downtime. So I'm not expecting any downtime for the repository because developers uses that repository from the server so very frequently. If there is any downtime for the server, definitely that affects your repository on the server. Automatically, developers would be affected, right? So we are not expecting any downtime. If you have your servers and your repository is running on the servers, then we need to make sure we always look after these things: server performance and then high availability. But I'm not too much worried about these servers. So I want my repository to be created on cloud. So going with cloud. So why cloud repository? What are the advantages then?
Then we just map to maximum access.
Yes. See, the first thing is whatever the drawbacks we have with server-based repositories, these two drawbacks we can overcome with the help of cloud. How? How we can overcome them? So you all use Google Drives, right?
Yes.
So do you know that? Did you ever see any concept called "I'm not able to access Google Drive"? So very rare, right? Very rare. Recently that happened, but that's very rare, right? And that means that is because of server performances where your data is stored, Google Drive data, or else that could be because of right availability issues. So now this is the problem if you go with server-based repositories. Now, as an end user, I'm not worried about these problems. What all I need is I just want to use my repositories with high availability concept. Am I clear? So if you want to have your high availability, firstly, I choose an cloud-based repository so that I can create my repositories on that particular cloud-based repository. I can start accessing them without any maintenance, right? I'm not worried about the maintenance at all. So maintenance, that kind of caring will be done by the provider. Who is the provider? So here we talk about GitHub. GitHub is one of the cloud-based repository tools, and where we can create repositories on their cloud. Then once my repository is created on GitHub, so do I need to worry about servers? First of all, I don't even know where are the servers. Yeah, but so GitHub is the best example for cloud-based repositories. That's one of the mostly used tool for GitHub as in cloud-based repository, which is owned by the Microsoft. That's owned by the Microsoft. So, and other examples for server-based repositories, cloud-based repositories, GitHub. Server-based repositories are Git is also a server-based repository. So Git, TFS, Bitbucket, Subversion, these are all server-based repositories, whereas GitHub is the repository which is available on cloud-based. And moreover, since I'm creating my GitHub repositories, of course they are on cloud, can I access them globally?
Yes.
Global access, that's advantage. Now, but the question, if I create my repositories on cloud, is my repository secured? Because some people think that this is my project code, but the project is available on my cloud repository, which is GitHub. Is it secured? Yes, we can provide securities. We can provide any type of securities. Who can access, who cannot access, who can do the changes, who cannot do the changes. We can provide all type of securities. That's possible. Okay. Well, now that is what we're going to start with today. GitHub. So GitHub or Git, both are same. The only difference is Git is server-based, GitHub is cloud-based. Rest of the things, that means the architecture and the commands, how you create repositories, and the performance, everything is same. Every command is single command is same. The only difference is that Git is on server-based, whereas GitHub is cloud-based. Now, that is what we're going to understand now. Its architecture. What is Git or GitHub architecture? We talk about that architecture. And if you understand this architecture, any other repositories in the future. For example, if you get a chance to work with TFS or Bitbucket, then those repositories also work with same kind of architecture, but there is a slight difference. We'll talk about that. I will compare it. I will do comparisons. So what is that architecture? Let's talk about the architecture now. So first, go with creating a repository on GitHub. Let's say I'm creating a GitHub repository. That is my GitHub repository. So how do you create them? We'll talk about all the steps. GitHub repository. So can I call this repository as centralized repository? Yes. You can call it centralized repository, or you can call it remote repository. So now we have a centralized repository, remote repository created. Where is it created? On GitHub. Okay. Fine. Then as a developer, I like to do some changes onto that repository. That means as a developer, I create some files of my project. Then I save my files to the repository. Okay. So how do we do that? What are the steps we follow? Okay, let's move on to that first. Now, so we have some developers in our project. Let's say developer 1, developer 2. There are some developers. Developer 3, some developers. We have some developers. So we have 4 developers. Okay. Now, as a developer 1, I want to do some changes on my project repository. Then how do I do those changes? That means I'm creating my project related files. Okay. So do I log into that repository? And then do I do the changes on the repository itself? Say, remote repository is only for saving the changes you have done. That means you cannot log into the repository as a developer. That's not possible. If I cannot log into that remote repository, then how do I do the changes on the repository? Is it clear? So that's why developers first do the changes related to the project on local repository. What is that? Local repository. What is a local repository? Local repository is nothing but this is a copy of your remote repository. So that's a copy of your remote repository. Means every developer, if they want to do the changes onto the project repository, first they need to have a copy of remote repository to where? Onto their local system. Understand? So how do you create that copy on my local system? So let me say, for example, so this is my remote repository. Okay, where is it? That is on GitHub. Then as a developer, I want to do some changes on that repository. And do I need to log into the repository? Then I do the changes on the remote repository? No. So I do the changes on my local repository. What is a local repository? Copy of your remote into local. There. So for example, let me show you a simple example how local repository looks like. This is my local repository. Okay, I have a copy of the remote repository on my local. See, local repository is nothing but just like a folder. That is just a folder. Okay, open that folder and you create all your related files, project files. So I create some files over here. Let's create some file, something like, sorry. So that's my file. So where the file is created on local repository, not remote, local repository. So where is that repository? That's on my local system. So that is what is your local repository. Local repository is just a folder. And on that local repository, I do my changes Once I do the changes, what is the next thing? Commit all the changes from local to the remote. That is how it is done. So you don't do the changes on the remote repository straight away. You do the changes first on your local repository, then you commit the changes to the remote repository. Okay. But the question is, how do you get that remote repository onto local? Say I said local repository is a copy, right? It's a replica, right? How do you get that replica of remote into local? So as a developer, I just open some git bash. So what is the git bash? Git bash is a command line. Okay, we'll talk about it. I run a command called, what is the command is git clone. So git clone. What do you mean by cloning? Copying. So we are creating a copy. So we are creating a copy of your remote repository onto local. Okay. So we call it local repository, or technically we call it working copy. What is that? Working copy. Okay. Then, so how many developers we have? 4 developers. Every developer must do clone or not? Right? Every developer must do cloning. That is what is cloning. So every developer first clone the repository. That is what we talk about cloning. We have 4 developers or 40 developers. Developers must do clone first. And what happens when they clone it? Yeah, there will be a working copy created. That is what is working copy. So what we call that operation or command git clone. Okay, fine. So once you clone it, now on the local repository, I do my changes. So as a developer, what do you mean by changes? I can create some files. I can modify files. I can delete files. I can rename files. We can do all these things on the repository, right? Yes, we can do all these things on the repository. That is what we call changes. Now, so where do we do the changes? On the working copy only. So for example, this is my working copy. That's my repository. So my repository is somewhere here, but I want to do the changes in some other location, somewhere in D drive. Can I do it? No. Why? The changes you do in that working copy, only those changes as considered as your repository changes. Those are considered as your project changes. So all the changes must be done related to the project, related to the repository, must be done within the working copy. Okay. So remember that. That's what we call working copy. Working copy or local repository. But how do you get that copy? Using git clone. So now back to the architecture. Then let's say I'm creating a file. Create hello.java file. Let's create that file. Some file. So once the file is created, then the second step is git add. That's my second step. So what git add does? So these are all your working copies, right? Local repositories. Now every repository maintains its own memory. We call it cache. What is cache means? Memory, right? Temporary memory. Now even we have that on system, right? We call them memory. So what is the purpose of memory? In general terms, temporary storage or permanent storage? Temporary storage. So every repository maintains that storage, which we call it cache or temporary memory. So when you do the changes on that repository, you just add the changes to the cache. So what we call it? Git add or else technically we call it staging. What is that? Staging. So what happens when you stage it? The files or the changes you have done on the local repository will be staged or will be added to the cache. Let's take temporary memory or local memory. So, and then which is what we call staging. Okay, that is what we call staging. You can call it unstaged, but we're not going into that detail. I'll show you what is staging, unstaging technically later. So that is the second step. So what I have done first, I've created some changes. Okay, created hello.java file. Then the third step, I have staged it. That means added files to the cache, local memory. Okay. Once the files have been staged or added, and the next step is commit. So now we're going with commit. Now what is committing means? Adding all the changes you have done from the memory to the repository. So we have staged them, right? We have added, where they're added to the temporary memory. And from the temporary memory, you're adding the changes to the permanent storage, which is onto the local repository. So this is something like you have memory, from there you're adding them to the hard disk, something like this. So first you stage them, you add them to the cache, and from there you commit the changes, or you save all the changes permanently now. The changes are permanent. When you add the changes to the cache, then those changes are only temporary. When you commit them, the changes are saved permanently onto the local repository. Okay. Now what is after that? So where are the changes now? Changes have been committed to local repository only. But where do you want to have all the changes to be saved onto the remote repository? Because the concept is sharing. How the sharing happens through remote repository. Let's go with push all the changes to the remote repository. Now we are pushing. So now here we talk about git push. So what is pushing then? Pushing means saving all the changes from remote local repository to the remote repository. That is what is pushing. So open those windows, please. Close the windows. Can you open it? Yeah, thank you. So now here the steps are, the first step is, what is the first step? First, clone it. Clone is mandatory, that's the first step. And once you clone it, in the second step, you do the necessary changes. You can create files, delete files, you can modify them. And in the third stage, what is the third step? Adding, staging, yeah, add to the memory. And then fourth step is, and fifth step is, so push. This is how repository concept works. That's a life cycle. So the fourth step is commit, git commit, and then fifth step is git push. Now let's discuss few points regarding the commit. So we have committed and then it was pushed, right? So what is pushed, or what happens when you commit it? For example, I'm committing it. What happens when you commit it? Sorry. So save all the changes, right? Save the changes. What do you mean by changes? Like I said, when I say changes means we can create files, we can delete, we can do all these kind of modifications anyway. So changes are being saved to the local repository. Your files, your change files, your modified files have been saved. Okay, what is next? What happens when you commit it? So we have been talking about something. from the beginning. What is that? If any developer or every developer, when they do something, some changes to the file, what will be created? Version. Okay. So there will be a log created. So there will be a log. I'm a developer. I have done some commits. If I do a commit, there will be commit log created. In that log, what do you see? You see that version, or you can say commit ID. We call it commit ID. Instead of saying so version, we call it commit ID. In some other repositories like Subversion, we call them version IDs, but here we call them commit IDs. So what do you see in the commit ID? For example, let me show you an example. So now this is my log. You see the log? That's a log. What do you see in the log? What is that? Commit ID or version ID. Is it in some sequence? No, there is no sequence for this. That is a random ID. It has about 32 numbers. Okay, that's what is called commit ID. So when this log is created, when the log is created, when it is committed. So if I do 100 commits, there will be 100 logs. 1,000 logs. If you have 50 developers, every developer has their own logs. Okay, so that. What else we have in that? We can call it commit ID. In terms of Git, we call it SHA ID. Whatever you call it, you can call it version, commit ID, or SHA ID. Okay, so that's the first thing you see. And what else you see in the log? Developer name. So which developer has committed? So we can see the developer name. That means, are we maintaining the history?
Yes.
Who has done what? I can see the developer name. And then developer email ID as well. Which developer? What's his email ID? And what else? Date and then time. We can see the date and time. So when that was committed, so on so and so day, that was committed. Okay, well, so this is what exactly your log contains. That's your log information. And also you can see some message there. We can provide some message when you commit it. For example, how do you commit it? The command is git commit. This is a command to commit. And then -m, it's a syntax. And then m stands for message. What is that message? We can give some message. For example, I'm a developer 1. I'm committing it. So what changes I have done? I have created hello.java file. That is some message. You can provide any message. Why we need that message? Yes. So in the future, if I want to refer those again, I can see that, okay, fine, on that particular commit. So what happened? File was created, hello file was created. I can see that message as well. So that is what exactly the log contains. Log contains the information. So what information? Your commit IDs, developer name, developer email ID, date and time, plus the message. Okay, fine. Then once we commit it, what is the next step is push. Okay, let's go with git push. Now tell me what will be pushed onto the remote repository. Okay, the files are data. Okay, then what? Logs? Yes or no? So where is this information is? Initially on the local repository, then we push it. When we push it, information, that means your files as well as logs, they have been pushed onto the remote repository. Once all the changes plus logs are pushed onto the remote repository, then those changes are available on remote repository. Now they can be accessed by some other developers for sharing purpose. Okay, clear? Now coming to developer 2 now. Let's talk about developer 2. So did developer 2 has a working copy? Yes. Yes, there is a working copy for developer 2. Now when this working copy was cloned, is it before the developer 1 commit or after developer 1 commit?
After
When the working copy was cloned? Before, right? Initially, when I have created my local repository, sorry, remote repository, at that time itself, every developer has cloned it. So it was a new repository. Into that new repository, developer 1 has committed and then pushed a change. That means is my remote repository is updated or not? Then as a developer 2, if I want to access the changes done by the developer 1 to the remote repository, how do I access the changes? Correct. So I must update my local repository. Why update it? Since some other developers, so they have already done some pushes, commits onto the repository, I must update my local repository. If I update my local repository, what is update means? Synchronizing our local repository with remote repository. That is what we call update. If I update it, then I can see that modification, right? Is it clear what is update means? Now let's update it. So how do we update it? So the command is git pull. So let's go with git pull. That means we are pulling the changes. So this is quite opposite to push. Push means pushing the changes from local to remote. Pulling means getting the updates from remote to local. Okay, right. So now, can I see that hello file? Yes. Since my local repository is updated, I can see that file. Now, do I see only the file? Or can I see the log as well? I can see the log. Okay. So I have updated, since I have updated my local repository, I can see the log plus file, the data. Okay. Now, as a developer 2, I'm modifying that file now. So I have added some code to that particular file. The file has been modified. Okay. So developer 1 has created it. Developer 2 has modified it. Now tell me what are the next steps. Git add. See, add the changes. That means you save the changes to the memory first, cache it. And once you add it, then next step is then go with commit. Git commit. After that, so you follow the same steps. No change in the steps. Okay. So then you go with git push. So now as a developer 3, I want to access all the changes available on remote repository. Update it first. Yes. See, if you want to see the changes on the remote repository, first update your local repository, then you'll be able to see all the changes. Okay. First update it. Again, same steps. So go with update. That means pull. And once you pull it, you can do the modifications, adding, committing, pushing. Okay. Now tell me the difference between clone versus pull. What's the difference between these two? Clone does
What is overriding the first?
once. So clone actually is used for the first time. For example, there is a new developer. He is joining my team. He is a new developer. Let's say, let's create a developer. He is a developer, and he is a new developer. And since he is a new developer and he wants to access the project code, he has to first clone it. And once we clone it, and from next time onwards, pull it, update it. So cloning is done only for the first time, and pulling will be happening frequently, any number of times. If you want to have a local copy, you clone it. Or if you want to update that copy already you have, then use git pull. Okay, that's the difference between clone versus pull. Okay, now what we call this kind of architecture now? There is a name for this architecture. You understand the architecture now? Very simple. What we call this architecture? Let's call this architecture is DVCS architecture. DVCS means so distributed version control system architecture. So what is distributed? Why we call it distributed? Why we call this distributed? Share. Information can be shared even any repository. What is distributed? Right. So let me give you an example. So there are some developers, let's say dev 1, dev 2. We have some number of developers. 10 developers. Okay. Now all these 10 developers, so they have done some changes to the local repository, and then they have some commits. Let's say each has about 20 commits. So they have some commits, 20 commits each. Some developers have 25 commits. Some developers have 10 commits. See, this is not required to push every time when you have a commit. I can do hundreds of commits locally, then I can go with one push. Understand? I can go with so 10 commits or 20 commits, number of commits on local repository, but how many times I can push it? That's my choice. I can do one push, two pushes, but I don't push it every time. So developers actually they maintain some particular process when they need to be pushed. Okay, they have some kind of a process anyway. So there are some commits and number of developers. How many times they are pushing it? Let's say some minimum number of pushes. He is pushing. Developer 1 is doing 2 pushes or 1 push, something like this. So where the changes have been pushed into? Where the changes are pushed? To the remote repository. Okay. Right. How many times we are trying to? Developers are trying to access the remote repository. So minimum number of times. Am I clear? Okay. For example, let's say there is no concept of commit. There is no commit concept to local repository. Straight away, what do? Push it to the where? Remote repository. If there is no push concept, so there is no commit concept, we are pushing straight away onto the remote repository. There is no push. Now, how many times these developers will be, small mistake. Okay. There is no commit concept, there is only push concept. So they must push it about number of times to the remote repository, right? How many pushes? Let's say 20, 30, 50 pushes. The number of times, so they're accessing the remote repository has been increased. So there will be load on the remote repository or not? So what we call that architecture, that is what we call client server architecture. So what is the drawback with the client server architecture? Number of times users access the remote repository is increased. so that there will be load on the remote repository. Once. So is the point clear? Understand the point? But so in terms of DVCS architecture, so if you go with DVCS architecture, this is your DVCS architecture. In this architecture, so developers can do number of commits onto the local repository, and they can do minimum number of pushes. Now, what is distributed now? Can we call it DVCS distributed architecture now? Yes. Okay. Or else tell me the advantage of this architecture. Tell me the advantage of this architecture.
Minimum number of pushes.
Minimum number of pushes. Okay, we are doing minimum number of pushes. What is the advantage then?
Load.
Load on the remote repository is increased. How that is increased?
More times commits.
Yeah, by decreasing the okay, fine. Let me put it another way. So now in DVCS architecture, load is distributed. I can say that. How that is distributed? By allowing the users to do local commits, so that developers can do the commits to the local repository. That way, I have distributed the load on the local repository. So instead of accessing the remote repository straight away, the load on the remote repository is distributed to the local repository. So can we call this distributed version control system architecture now? What is distributed? The load is distributed to the local repositories. This is why we call them distributed version control system architecture. So how about in client server architecture? So no commits, only push to the remote repository. Then there will be load on the server or remote repository.
First developer, whatever commit, then only first developer working space they are stored.
Sorry.
Developer whatever git commit, that store in working space.
Yeah. So that is a commit concept. The changes which are done by the developers, so they are saved or committed to the working copy of local repository. From there you push it. Okay. So now this is your repositories basically are divided into two categories based upon the architecture. So what is that architecture? We have based upon the architecture, repositories are of two types. The first is DVCS repositories, second is client server architecture. So if you go with client server architecture, SVN subversion is one of the example which follows client server architecture. In DVCS, you have Git and GitHub, both are. These are DVCS architecture examples. So that's why, see, in the past, so we used to work with subversion, but after Git, DVCS architecture repositories been introduced, it's all Git or GitHub. Okay. Well, yeah. Questions? Anyone? Any questions?
DVCS Git commit after Git push. Client server only.
Yes, correct.
There is no Git commit.
Correct. So in DVCS architecture, we have two steps: commit plus push. But whereas in client server architecture, it's only push the changes. So that's not we call it push actually. So for your understanding, I said push, but technically we call it commit. But where do you commit it? Remote repository. So there is no concept of push actually. We have only commit, but those commits are actually to the remote repository. There is no local commits, only remote commits. But here in DVCS, we have commit to local repository. So the term difference, So in commits, client-server architecture, commit means commit to the remote repository. In DVCs, commit means local repository. Push means remote repository. That's a change. Okay. Yeah. Any other questions?
So after changes of developer one,
Yeah.
he commits data into remote.
Local.
Then how developer to need to update? He will get any message?
No. So if you do any changes, so for example, there are some developer one, he has done some changes to some file and committed and then pushed, right? So these developers, they won't be notified. They don't get any notifications. If you get notifications, you get thousands of notifications. That's not possible to notify the other developers every time. That's not a good concept, because only for the notification purpose, you are triggering thousands of emails. That's not a good practice. Okay.
Whenever push only, it push only, they update.
So that is the reason there is a solution for this. If I don't know as a developer one has already committed and pushed, I don't know that, right? Then still without knowing that, I am doing my modifications. For example, you are a developer one, I'm a developer two. Okay. So I'm a developer two. Let's say you're a developer three. Let's go with that example. Now I'm modifying that file. You're also modifying the same file. You don't know that I already have modified it and committed, but you are still modifying the same file. Then you are committing and pushing it. That is called conflict. So in order to resolve these kind of conflicts, so the concept is pull. Before you commit the changes or push the changes, make sure you update your local repository. Once you have the updates, then you start commit and push it.
So if it is done simultaneously,
That's a conflict. That's again a conflict. So if both developers are doing commits same time, and then so if same time is never possible, there will be at least so fraction of seconds difference will be there. If that happens same time, it is going to throw some error saying that there's a conflict. Try this again. Then you push it, but again there will be a conflict. We'll talk about the conflict later in the future. So in our third or fourth session, we'll talk about that. So what happens if same developers are modifying same file, same lines? So that is what we call a conflict. Okay.
So what if you want to remove the modifications? Like if you want to have the basic files, what if you want to?
Yeah, you have the versioning concept, right? So you have the versioning concept. So what is versioning concept? So for example, as a developer 4, now, so what file I access? Whatever the updated file we have on the remote repository, I access that file. But I don't want that file. Instead, I want the file initially. So initially there was a file. I want that actual file. Yeah, you can do it. You have the versioning concept, right? So you can see that. So when the file was recently modified, and who has modified, what was the version? Now you can go back to particular version. You can switch to that on the date. On so and so commit, you can switch it. Now you can see that. You can get that file again. Okay. You can switch to any version, anytime, any file. Okay. So we have other concept for the versioning concept. There are different ways you can do version control. Okay.
So in the user to cache and
Sorry.
in working base necessary to cache and hard disk.
So there, you don't worry about all this cache and hard disk. So that is all internal concept. But you stage them and then you commit it. So rest of the things, technically what happens in the background, that will be taken care by the repository. Okay. So, but you stage it and then commit it. So there is another purpose of going with adding or staging. So we'll talk about that as well in tomorrow's session. So when we create Git repositories, GitHub repository, when we clone it, then we'll see the practical part, why we need to stage it. Okay, there is a practical actual example. So we'll be discussing that in detail. Yeah, any other questions? No. So what do you do for today? Just do one thing. Very simple. Just go with github.com. That's your GitHub URL. That's URL, github.com. And then go with sign out. create an account on GitHub. Just create an account. So sign up for an account. Just enter the username, email ID, password. Then you start creating an account. Get your GitHub account ready for today. Very simple. Just go to github.com, then you sign up, enter your email details and then these details. Get your account ready, and then in tomorrow's session, so we'll be starting with creating GitHub repository, and then we clone it, and then commit, and then push. So we'll commit number of files, and we'll talk about it. That is the first thing you do. And second thing is, so back to the architecture. So we have developers, right? So how developers clone the repository? Using git commands. And if you want to run some git commands, you must, on the developer side, you must have git installed. Yes. Now even you do that also. Now try to install git on your Windows. Why Windows? See, think in terms of a developer. You are a developer, you are committing your code. Developers mostly they work on Windows systems, right? That's the reason you install the git on your Windows. Okay, so do that as well. Git for Windows. Just search for git for Windows, and that's the URL gitsem.com. Download Windows. So click here to download, and once it is downloaded, you can see that file. You can find this file even on the Google Drive. Open it. That's, where is that git? That is your git. So double click on it. It is going to install git. So that will be installing your git, and we call it git bash. What is git bash then? So just run it. So go with the default steps, go with next. So I just skip it anyway, but that is a Windows installation, you will be able to do it. Now once it is installed, you must be able to see that git bash. What is a git bash? The name itself says it's a bash, it's a command line. That is your git command line. So what is the command you want to run? Any git related command, you run it through git bash. So this is what you do, and you have two things, very simple things. You can do this easily. So just about 5 minutes of time. The first thing is create GitHub account, and second is so install Git for Windows. So we call it git bash, git command line. Okay, so install that, but make sure you understand the differences. So this is also an important question. So what are the types of repositories you have been working with? So been working with DBCS repositories. Client server, we don't work with it, but just say, so I've been working with DBCS architecture repositories, which is Git or GitHub. Okay, yeah.
We are using GitHub repositories.
Yeah.
Instead of GitHub repository, is there any other repositories?
Cloud repositories?
Yeah, cloud.
So even Bitbucket has a cloud repository. Bitbucket. So just like GitHub, they have local repositories, also they have cloud repositories. Even Bitbucket has cloud repositories, local repositories.
Then why we are using GitHub?
GitHub, so because GitHub follows DBCS architecture. That's architecture level difference. Because of that reason, we use GitHub. Okay. Well, yeah. Any other questions? No questions? Well, so regarding your weekend sessions, so this weekend onwards, Saturday, Sunday, we'll be starting our AWS sessions, and the time is 8:30 to 10:30. So around 2 hours. So Saturday, Sunday, from this weekend, that's your time. 8:30 to 10:30. Okay. Thank you.
Saturday question, the file renewal, mostly